Hello, this is Priya, your maths tutor, and once again, I welcome you all on my channel, Vidya. So, students, in the last session, we have started exercise 8.3 of the chapter 8, Trigonometry, of which we have already completed question number 1 and 2. So, today we are going to start question number 3. So, let's start the question number 3. In the question number 3, we have choose the correct option, justify your choice. So, the first part we have is 9 secant square a minus 9 tan square a is equals to. So we need to find the value of 9 secant square a minus 9 tan square a. Now we know that we have identity secant square a minus tan square a is equals to 1, right? And if I will take 9 common among these two, what I will get? 9 secant square a minus tan square a. And secant square a minus tan square a is 1. So it is 9 times 1, which is equals to 9. So that is for the option question number 1, option B, 9 is a correct answer, right? Wonderful. Now, in the second part, we have 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. We need to find its value. So let's solve it. We have 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta, right? Now, we'll substitute the values of tan, cot, secant and cosecant. We know that tan is equals to sine upon cos and secant is 1 upon cos. So, we'll write sine theta upon cos theta is the value of tan theta and secant theta 1 upon cos theta. Similarly, we'll substitute the value of cot theta and cosecant theta. Cot theta is equals to cos theta upon sine theta minus cosecant theta is equals to 1 upon sine theta, right? Now, we will simplify both the terms. So, in the first bracket, we got the LCM as cos theta and the term we got is cos theta plus sine theta plus 1. And in the second bracket, we got sine theta as LCM and in the numerator, we got sine theta plus cos theta minus 1, right? Now we need to multiply these two terms. So on multiplying in the denominator, we got cos theta into sine theta, right? Now, if we'll observe the term very carefully, we can see that cos theta plus 1, cos theta plus sine theta plus 1, cos theta plus sine theta minus 1. That is A plus B into A minus B, right? So we can use identity A plus B into A minus B, which is equals to A square minus B square, where A is cos theta plus sine theta and B is 1, right? So the value of B we have is 1. Now, A square minus B square, that is cos theta plus sine theta whole square, which is A square minus B square, that is 1 square, right? Now we'll apply the identity A plus B whole square. So we'll get cos square theta plus sine square theta plus 2 cos theta sine theta minus 1 upon cos theta sine theta. Now cos square theta plus sine square theta is equals to 1. So we'll get 1 plus 2 sine theta cos theta minus 1 upon cos theta sine theta. This 1 plus 1 and minus 1 will get cancelled out. So we are left with 2 sine theta cos theta upon cos theta sine theta, where cos and cos, sine and sine will get cancelled out. So we got the value as 2. So that is option C is the correct answer. Okay? Is it clear to everyone? Wonderful. Now for the third part, we have secant A plus tan A into 1 minus secant A. So let's solve it. So in the third part, we have secant A minus Is it minus or plus? Plus tan A into 1 minus sine A. Now, again, what we'll do? We will substitute the value of secant and tan. Secant is 1 upon cos, tan is sine upon cos. So we have A here. So we'll put A, sine A, cos A into 1 minus sine A. Now, in the left bracket, we'll take the LCM and we got 1 plus sine A upon cos A into 1 minus sine A. Now, we have A plus B into A minus B. That is A square minus B square upon cos A. Now, 1 minus sine square A is equals to cos square A divided by cos A. Cos A into cos square A. Here we'll get 1 cos cancel, will cancel 1 cos. So we are left with cos A. So that is option D is a correct answer, right? Wonderful. Now, in the D part, we have 1 plus tan square A upon 1 plus cot square A. So let's solve it. One plus, it was tan on the numerator, right? 1 plus tan square A upon 1 plus cot square A, right? So we need to solve this expression now. So what we'll do? We will either convert this tan in terms of cot or this cot in terms of tan. So let's convert the cot in terms of tan. So we know that cot is equal to 1 upon tan. So we'll write 1 upon tan square A, right? Now, for the denominator, we'll take the LCM. And what we will get? 1 plus tan square A upon LCM will get is tan square A. And in the numerator, we'll get tan square A plus 1, right? So, now we'll have 1 plus tan square A upon this part. And when this is dividing, and when we want to convert into multiplication, what we'll do? We will just take the reciprocal of the denominator. So it will be tan square A upon 1 plus tan square A. So this 1 plus tan square A and 1 plus tan square A will cancel out each other. So we are left with tan square A. That is, again, option D is a correct answer, right? Wonderful. So with this, we have completed the question number 3. Now we'll start the question number 4. So let's start the question number 4. In the question 4, we have prove the following identities where the angles involved are the acute angles for which the expressions are identified. So here the angles, the theta, the A, whatever the angle given, they all are the acute angles. That is, their value is less than 90 degree. So we need to solve the expression left hand side and right hand side. And we need to prove that left hand side is equal to right hand side. So let's solve the first part. Let's take the left hand side. We can either take left hand side or the right hand side. In the some questions, we need to solve the left and right both. Okay. So let's try to solve the left hand side. So here we have cosecant theta minus cot theta whole square. We need to prove that this will equals to 1 minus cos theta upon 1 plus cos theta. So let's solve it. Now, cosecant theta. Cosecant theta is equals to 1 upon cot, 1 upon sine theta minus cos theta is equals to cos theta upon sine theta. We'll take the square of it. Now we'll apply the identity. Before that, we'll take the LCM. So LCM will got sine theta, and in the numerator we got 1 minus cos theta. So we'll take the whole square of it. Now A minus B whole square. So it will be A square plus B square minus 2 times A times B. That is 2 times 1 times cos theta. So it will be 2 cos theta. And in the denominator, we have sine square theta, right? Or what we can do here, yeah, okay. Let's ignore this step. So we'll do it in easier way. So what the easier way is, we'll write the upper term as it is, and the lower term we have is sine square theta. And what we'll do here, we will convert sine square theta into cos. So it will be sine square theta plus cos square theta is 1. So sine square theta is 1 minus cos square theta, right? Why we have done this step? Because in the answer, we want the term in terms of cos theta. So that's why we have tried to eliminate sine and we have converted into the cos term, okay? Now, herein we can apply the identity in the denominator, a square minus b square, which is a minus b into a plus b, right? Oh, it was square. Now, this square and the one term will cancel out each other. So we are left with 1 minus cos theta upon 1 plus cos theta. And this is equals to right hand side. Is it clear? So we'll write hence proved. So we need to prove that whether we need to prove left hand side is equals to right hand side. So we have started from the left hand side. Solving the left hand side, we got a term which is equals to right hand side. Hence, left hand side is equals to right hand side. Hence, proved. Is it clear? Wonderful. Okay, now let's solve the part B. So in the part B, we have to prove that cos A upon 1 plus sin A plus 1 plus sin A upon cos A is equals to 2 secant A. So let's again take the left hand side. And left hand side we have is cos A upon 1 plus sin A plus 1 plus sin A upon cos A. Both are the fractions, so we'll take the LCM of it. So let's add the two fractions. So in the denominator, we'll get cos A into 1 plus sin A. And in the numerator, we'll get cos square A, cos A into cos A. Multiply both the terms, it will be cos square A. 1 plus sin A into 1 plus sin A. It will be 1 plus sin A whole square, right? Now, it is cos square A. Now we'll apply the identity here. So it will be A plus B whole square. That is A square plus B square plus 2AB, right? And in the denominator, we have cos A into 1 plus sin A. Now, this cos square A plus sin square A is equals to 1. So we'll put 1 and 1 square is 1 adds 2 sin A. And in the denominator, we have cos A into 1 plus sin A. Now this 1 plus 1 is 2. So 2 plus 2 sin A upon cos A into 1 plus sin A. Now we'll take 2 common. So we are left with 1 plus sin A in the numerator. And in the denominator, we have cos A into 1 plus sin A. This 1 plus sin A and 1 plus sin A will cancel out each other. So we are left with 2 upon cos A. And we know that 1 upon cos A is equals to secant A. So we got the value as 2 secant A. This is what we have to prove. So that is on solving the right hand side, we got 2 secant A, which is equals to left hand side, and hence proved. Okay, I hope it is clear to everyone. Wonderful. So till now we have solved the 2 parts of the question number 4. So in the next video, next session, we'll start the question number 4, part 3rd. So for that, stay tuned. Bye-bye. Have a nice day.